All right. Hi, everyone. We are Team Animyth. My name is Sky.
My name is Sherry.
All right. First, please enjoy a quick demo video. Yeah. So that's the video. This video showed a character generated by Animyth navigating around in a platformer game environment. Super Mario Bros. Is a classic example of this type of game, where characters are usually shown from their side views, except this mushroom guy. The animation came from the sprite sheet. The sprite sheet contains multiple graphics. They are called keyframes. Animyth's current focus is about generating this kind of sprite sheets that contain the keyframes for the essential actions in this type of game: idle, run, and jump. The motivation behind Animyth is based on my personal game development journey. Making sprite sheets requires artistic skills, and this process is not only time-consuming but also requires intensive labor. I hope I could make a tool where I could describe the character and action in words, and then a decent sprite sheet would be generated within minutes or even seconds. And so the idea has transitioned to reality. Animyth's architecture begins from user text input. The character description is transformed to a tag-like prompt by GPT-4. The action word helps to select the sprite sheet template derived from the maximal animation keyframes. The tag-like prompt is then processed by the Stable Diffusion checkpoint with the pixel style LoRa, and that block takes care of the text-to-image generation. ControlNet provides a structured framework that it uses OpenPose to detect the pose from a template and use the pose to guide the image generation. And before we deploy the sprite sheet into any game engine, we need to remove the background. Let's take a closer look into the text-to-image generation web UI. First, at the top is the Stable Diffusion checkpoint that we used. This is where the tag-like input will go to. It is important to include a reference to the LoRa. At the bottom is where the control net is. Inside the control net, we upload the template image, and we choose the OpenPose preprocessor for the pose detection. And that's the pose detection. Previously, this is the result. Next, I will hand over to Sherry.
We manually generated our data by a text description of a pixel-styled character, and it contains 8 distinct characters with 3 actions: idle, run, and jump. And this is essential for platformer games. And we developed 4 rubric of our model assessment. We can see from the left corner of the girl character, it's a good example of our sample. And for the boy character, it's scored lower because of it doesn't match the description and it needs manually editing. And for the robot character, we can see that it's a necessity of manual editing, and it doesn't meet the entirely given description. These samples are randomly generated, not selectively chosen, and this is accurately to reflect our model's performance. Moving on to we can see there is an impressive rate of 4.2 out of 5 of our model, and we can see that character consistency and animation smoothness stands out from our model. And we can see we got like 3.9 score of manual editing, that we really need some manual editing from our model. And for the match description score, we got 4.0. It reflects well with our model's ability to match our design intention. For our future projects like Animyth, we have like 4 key enhancements. First, we need to expand our sprite sheet template range, possibly integrating with ActionGPT to obtain more actions and variations. And we are considering about to develop an all-in-one template to generate sprite sheet for better consistency. We want to make our process to be autonomous to utilize Stable Diffusion Web UI API. And we are considering about to develop a more robust revaluation framework for better evaluation. And thank you. We are honored to be here to share our ideas, and we hope you like it.